In this video, we are going to be going over a couple of calculations with formulas. So we'll be talking about empirical and molecular formulas. So before we get to our calculations, we just need to review those two vocab terms. So empirical formula is the lowest whole number ratio of atoms in a compound. So if we have something like glucose. Glucose would be C6H12O6. That is the actual molecular formula because that's the number of atoms that it has. Its empirical formula would be the reduced form of that. So that would be CH2O. Sometimes the molecular formula and the empirical formula are the same. So for example, with water, water is H2O. It contains one oxygen, two hydrogens. So that is its molecular formula, but it's also its empirical formula because you can't reduce two and one. As a reminder, ionic compounds always need to be written as empirical formulas. So once you do the crisscross of your ions, make sure that you reduce it. Now, the reason why ionic compounds are always written as empirical formulas is in reality, ionic compounds are a giant crystal, like NaCl is a giant crystal of sodium ions attracted to chloride ions. So they're just giving you the ratio of the cation to anion. As I already addressed on the first slide, molecular compounds might also be empirical like we see with water, or with this last one here with sucrose, because of the 11 in there, you can't reduce that one. All right, we're pretty familiar with problems like this, where it tells us to calculate the percentage by mass of a particular element in a compound. So if we have calcium sulfate, that would be CaSO4, because calcium's +2, sulfate is -2. So we would figure out the total mass of calcium sulfate and then do the mass of sulfur, which is 32.06, over the mass of the whole compound times 100. So we are pretty good with an example like that. What we are going to be working on is the opposite. So given a percentage of the elements, you need to figure out what the compound's formula is. All right, so in these types of problems, you'll be given information like the compound is 80% element Z by mass and 20% element X by mass. Find its empirical formula. Now you have to remember your empirical formula gives you your mole ratio. So when we have water, H2O, it's two hydrogen atoms, one oxygen atom. That's the mole ratio, not the mass ratio. So you're going to have to take the percentages and get them into moles. Now, in order to do that, what we do is we assume that we have 100 grams of the compound. That way the math is really easy. That way we would have 80 grams of Z, 20 grams of X. Then we would use their masses off of the periodic table, if they were actual elements, to figure out the number of moles. Once we figure out the number of moles, then we would get a nice whole number ratio. The way that we do that is we divide by the smaller of the two moles that we got in the previous step. And then sometimes we need to do this fourth step of multiplying by an integer if that's necessary. We're going to go through an example on the next slide. All right, so adipic acid contains 49.32% carbon, 43.84% oxygen, and 6.85% hydrogen by mass. What is the empirical formula of adipic acid? So again, your empirical formula is based on moles. So we got to get some grams and then turn that into moles and then find a nice whole number ratio. Easiest way to do that is to assume that we have 100 grams of our sample. That way we would have 49.32 grams of carbon. We would have 43.84 grams of oxygen and 6.85 grams of hydrogen. Now, if you want to be difficult, you could assume that you had any amount. You could assume that you have 37 grams of the sample and then figure out what those percentages would correspond to, but 100 obviously works very easily. Then we need to find moles. So we're just going to find moles for each one of them. So you would use the masses off of the periodic table and put that into your calculator. You want to try to keep quite a few decimal places. You don't want to round too much at this point in time. Okay, we do the exact same thing with oxygen. And then we'll do the same thing with hydrogen too. All right, so this gives us our mole ratio, or our moles. Now we have to figure out our mole ratio. So essentially what this is saying is we have 4.1 and change of hydrogen. Oxygen is next. 2.74 of oxygen, and hydrogen 6.796. Now, you can't write a formula like that. That looks ridiculous. You can't round to the nearest whole number because that would require a lot of rounding. So now what you do is you pick out the smallest of those three mole numbers, so the 2.74. You divide each of these by 2.74. And that will give us a nice whole number ratio. Now, sometimes it will be a teeny bit off. So like this one here with carbon gives us 1.5 about. Oxygen is going to obviously give us 1. And hydrogen is 2.5. Okay, so we're getting a little better. Now my formula would be C 1.5 O and H 2.5. So we're still not at whole numbers, but you can see we're really close. Now a lot of times in this step, we'd have our final answer. It might be, 3, 5, 1, and we'd be good to go. We are almost good to go, and this is what that last piece of instructions were on the previous slide. You sometimes have to multiply by a whole number. So if we multiply by 2, then we would get C3O2H5. Now we would finally have our whole number, and we finally have our final answer. So these problems are a little bit longer, but they're not that difficult. To review, what we did was assume we have 100 grams. That part's easy. Then we find moles. That part is also easy. Then we divided by our smallest mole value, which was 2.74, to get our whole number ratio. A lot of times that's our last step. We did not have our whole number ratio yet because we had 1.5 and 2.5. We multiplied by 2 to get a 3 to 2 to 5 ratio. All right, this is our last type of problem for this video. And this is one that we did do in Regents, so once you look at an example, it might look familiar. So the empirical formula for adipic acid is C3H5O2. That just happens to be the one that was in our last example. The molecular mass of adipic acid is 146 grams per mole. What is the molecular formula? So we are looking for a multiple of the empirical formula. So the way that we do that is we add up the gram formula mass of the formula they gave us. So we do that real quickly. So for carbon, we got 3 carbons. Hydrogen, we have 5. Now we probably here would have been fine using whole number since what they gave us was a whole number. All right, so I get about 73 grams per mole. Then what I do is I take the mass they gave me, so the molecular mass, divided by the mass of the empirical formula, and I can see that that's going to give me just about 2. So what that means is my molecular formula needs to be twice as massive as my empirical formula. So I just take the empirical formula and multiply the subscripts by 2. So that's going to keep the same ratio, but would double the mass. So hopefully you remember doing those before.